Well, good afternoon, good evening, or good morning, depending on where you are in this world. Thank you for joining us today for the DevOps.com webinar, Top 5 Considerations for Operating a Kubernetes Environment at Scale. I'm Charlene O'Hanlon, and I am the moderator for today's event. Before we get started, I would like to go over just a few housekeeping items. First of all, today's session is being recorded and should be available on demand probably about an hour or so following the event, along with the slide deck. If you signed up for today's webinar, you will be receiving an email link to both the slide deck and the presentation, which also will be living on DevOps.com. So feel free to check any of those post-webinar if you miss any or all of today's event. Also, we will be asking today's panelists questions, so if you do have a question for our panelists at any time during the webinar, please feel free to use the control panel and submit your questions. And we'll take probably about 15 minutes or so before the end of the webinar to go through the audience questions. Okay, and with that, without further ado, I would like to introduce today's panelists. We have Marco Boketsky, who is co-founder and CTO at Keitaro, and Patrick Lin, who is Vice President of Products at SignalFx. Welcome, gentlemen.
Thank you, Charlene. Great. So good morning, good afternoon, good evening, everyone. Thanks for joining us. Where I'd like to start today with a little bit of background on what's changed as companies move toward deploying applications on cloud. And what the implications are for monitoring those cloud-native applications. I'll then turn it over to Marco to talk about their experience managing Kubernetes at scale, including a customer case study with the cloud-native app. And then we'll spend a few minutes talking about SignalFx's Kubernetes solution that Keitaro is using with its customers, and go into some details of what you can see, what kinds of problems you can find, and so on. And then we'll close with Marco coming back on to talk about where they plan to take SignalFx monitoring for Kubernetes next. Okay, great. So let's go ahead and start with the first part here. And I think that for folks who are coming on to listen to this webinar, most of this is not going to come as a surprise. The last few years have driven nothing short of a revolution when it comes to the underlying technology that companies are using to build and run applications. And the tip of that iceberg is the need to offer the software as a service, often backing mobile app, and to deliver that software early and often to support rapid innovation. What then underpins the resulting web service is a new application architecture on top of a containerized or sometimes even a serverless environment. But it's not just a technology shift, it's also an organizational and cultural one where the practice of building and releasing software has changed radically as well. Previously, you had a 1-2 step here with dev, their responsibility ending with the building of the software, and ops taking over to configure and monitor and support it. And now it's not at all uncommon to have developers involved quite intimately in the operations of what they've written. Now, on a single team, there are lots of benefits to this kind of collaboration, as it allows the team to move a lot faster. But when you extend this model to a larger organization, and when the larger organization embraces a microservices model as a whole, there are many downstream implications. The number of teams involved in building software increases because the pace with which they're delivering and the size of what they're delivering shrinking. The number of releases increases dramatically as well. And when they're trying to figure out what's going on when it's in production, there's a few orders of magnitude increase in the number of components that have to be monitored and the number of potential dependencies that have to be understood in order to isolate problems. Now, this is exactly the kind of environment that SignalFx is built towards with core features to support the trends, right? And so new architectures that we're seeing out there are scale out, and they require that you be able to monitor service-wide patterns, right? To look at things in aggregate rather than looking at things that are very specific to one host or the other. This is going to be very true in the Kubernetes environment. The new execution environments also tend to have shorter component lifespans, requiring very fast discovery of new elements and very high resolution monitoring to go with it. You also, going back to the previous slide, talking about how there are thousands of times more metrics and events to process across distributed teams, you need to have the ability to share context across these teams, share visibility across the changes in an environment. You need to have much better analytics and alerting to identify emerging trends rather than trying to react to a broken situation. And you do need to have the ability to look at things in real time to correlate issues across different dimensions in order to be able to minimize the time to recovery when you do have that problem. All of these things lead to a set of requirements that are different than anything designed and built before these underlying trends and changes, and any monitoring platform built without containers in mind is going to fail on multiple dimensions despite their ability to store and retrieve time series data. And so if you do find a solution that doesn't have aggregation of composite metrics, that's going to be a problem. If you don't have the ability to look at high resolution, as in 1 second metrics, that's going to be a problem. And you really do need to have the analytics, the high cardinality querying, the alerting, and so on to back it up. Okay. All right. So with that, let me turn it over to Marco to talk about their experience in managing and running Kubernetes.
Hi, everyone. So thank you, Patrick, for that. So let's move on and talk a little bit about Keitaro now for a moment. So Keitaro is a software company based out of Sweden from 2011 onwards, and we are present in 5 locations. We're roughly about 36 employees, and we do a lot of work within the open source and Linux domain. Basically, at the core of Keitaro is open source, and we strive to provide services particularly tailored at providing solutions or support with popular open source software out there. Then the Docker story for us started quite early on, and we really took the whole Docker revolution quite early on. Basically, we've started running Docker in production 3 years ago. Considering Docker is 4 years ago, you can imagine how that is. And then when Kubernetes came around, we started getting heavily involved in it, and we saw the potential it had. So right now, it's really that these 2 technologies, Docker and Kubernetes, are the core of our services. Our main customer base is in North America and in Europe, and the main segments that we cover are telecom, financial services, technology, media, and government. We do run quite a lot of Kubernetes deployments, and we do offer services for providing either custom Kubernetes solutions or black box Kubernetes, where we basically run the service for customers. If we can go to the next slide. So what today business objectives are really about, and what the main focus is when we go out and talk to our customers, is that the expectation for always on apps is really now at the highest tier. So everyone has business critical application in today's mobile era. Everything needs to be on, everything needs to be accessible, 0 downtime. And this is really important, and we see it from the mobile app developers all the way to the enterprises where we'll see very high volume transaction systems. When it comes to how this is supported, then obviously we have the whole shift. So we really need to have development operations organizations have tight collaboration in order to secure that those applications are really always on, that rolling out new updates and deployments go smooth, and that the customer experience is always satisfied. And this comes into play with Docker and Kubernetes and all this new cutting-edge technologies coming in that companies are really taking interest. And not only that, we're in the world today of big data and everything connected. So this is becoming much more an ecosystem of applications and services which needs to scale to very high demand. And finally, especially in the enterprise sector, we see a lot of interest in how to modernize application deployments and availability. Typically, you would have your standard monolithic enterprise applications out there, and every customer on the enterprise is looking, okay, how can we modernize this? How can we take this, what all this, startups out there in Silicon Valley and everywhere else are doing, and get it into our enterprise? Because we really want to benefit from that, and instead of having 12-month release cycles, to get down to weeks of release cycles. So one customer study that we're going to go through right now is Viderum is one of our customers, and Viderum is a software as a service provider for open data management platforms. Specifically in this case, Viderum has based their software as a service model on an open source software solution which is built in a very traditional web application way, and that software is CCAN. So CCAN itself is your normal web application, model view controller, so very standard, very typical. And this is in no way built, with microservices and everything else that we see today in the world. So what they want to do is, how can we take this framework and provide a software as a service offering without, investing and breaking the bank? So we came up with a proposal of how to actually build a setup of a deployment based on Kubernetes, DICE, workflow, traffic, Crunchy, Postgres, Ceph, Minio, so a lot of components to build this massive system to basically support scaling this application and delivering it to thousands of customers. And the work we've done has been built around really benefiting the Kubernetes built-in controls for scaling, for application service clustering, and utilizing all of the metrics that are coming in from Docker and Kubernetes in order to be able to really, one, scale, and two, distribute as well. The end result was that we have simplified the workflow and really encapsulated all of the complexity of the cluster for the developers. And I'm going to talk about that cluster complexity in a while. But what essentially is for developers is that you really don't want your developers to fully understand how the Kubernetes cluster and all these different components are built so that they can build their applications for that. So what we've managed to do is really have developers use a very simple deployment, rollback, rollout model without basically knowing underneath what's going on. So what we have accomplished is that we can have 100 data portals running per node, and this is not a high-power node, it's just a normal AWS medium-power node. There's zero downtime for deployment. It's easy to roll back, just very simple. Even the developer can do releases and can do rollbacks with just one command. And also, we have enabled deployment of new portals within seconds. And this is different from a traditional deployment of the software, which takes hours, if sometimes not days. So, moving forward to the next slide then, to talk a little about now scaling with Kubernetes, is that in a nutshell, scaling is pretty easy. It's fast, there's no downtime involved. Of course, this is the whole purpose of Kubernetes. So when you want to scale pods in Kubernetes, when you need to have more resources for a given service, it's happened within mere seconds, and you also have the possibility to build in auto-scaling and to benefit from the Kubernetes ecosystem of metrics and everything that gets fed into the system itself. What this allows you to do is to configure a system that can automatically scale up and down based on demand, rather than have a whole operations team monitoring and manually managing that. When it comes to then horizontally, if you want to scale out your Kubernetes cluster to have more performance within the cluster itself, then this is also supported. It's straightforward. Rolling out a new node within Kubernetes is as simple as literally just installing 2 pieces of software in a node. It's very straightforward, and also there's built-in advanced mechanisms for load distribution. And what that means is that you can literally shove in double the capacity inside your Kubernetes cluster by scaling it, and the cluster can then load balance itself so that it can distribute all applications evenly and reduce the load on the actual physical hardware or cloud infrastructure. So can we move to the next slide, please? Yes, thank you. So when it comes to deploying Kubernetes, there's always certain things that you have to have in mind. And one thing to note here is that Kubernetes is quite a complex framework. It's up to you to basically configure it and set it up in a way that will make sense for the use case. So the most important things about deploying Kubernetes is always to start with calculating all of the needed resources in advance to begin with setting up the cluster. So main points obviously CPU, memory, and storage. Once you have sorted out those things and you have defined a proper hardware sizing for initial cluster, you need to distribute the services across the cluster, especially if you're using databases, caching, workflow type applications on your cluster. So in that case, and I can say from our experience, we actually do run backend services quite a lot within our Kubernetes deployments. It is extremely important how this is set up within Kubernetes, because if you don't set them up properly, backend services typically are the ones that are the most consuming of resources. And what that can turn into is that you might have constraints where your database needs to grow, but now, because how you have configured things, you have different applications on the same node that have demands, and your database can end up, well, literally crashing or slowing everything down. So that is one really important thing, and I can tell from our experience that backend services and middleware services in Kubernetes actually work like a charm as long as you take proper measurements into account when deploying those. Number 3 here is implement good monitoring and metric tools, and this is something that I would stress to be of highly critical value. So Kubernetes and Docker itself produces a lot of metrics, and there's a lot of events happening within the system because especially within a very dynamic deployment of Kubernetes where you have a lot of different applications running, you would have a vast amount of metrics and events happening which dictate how you can manage and operate the cluster and, of course, all the applications and services running it. And I would stress that this is very important because it allows to be able to do smart things within the cluster, such as implementing autoscaling based on application metrics, not based on actual physical resources, but for instance, the amount of live visitors on a web application, or for instance, the amount of connections on a database, and then based on those, you can actually scale things rather than just based on CPU usage or RAM or disk and all of that. Of course, this goes hand in hand that Kubernetes has that basic setup for what a modern application cluster should look like, and this allows you to do quite a lot. There's a lot of tools in that toolbox, but the main power of Kubernetes comes in where you deploy additional things with it that really make it powerful. Some of which I can highlight, and I've highlighted in our customer case there. So DICE workflow is a very good example of providing easy way to deploy web applications and really allow developers to easily deploy and work with the cluster instead of going through and learning Kubernetes and how to deal with all the different objects in Kubernetes. Then, for instance, load balancers. So, of course, you can go with a hardware load balancer, but if not, you can go with obviously with a software load balancer. Just Traffic is a tool that came in quite recently, and it's really, really good. So all of the things that are built for this Kubernetes era in mind, and specifically that take Kubernetes as a use case and build their software solutions against Kubernetes or with Kubernetes features, are highly recommended when setting up Kubernetes clusters because they make it so much powerful, especially outside of the operations teams. Your operations teams, though, always need to know Kubernetes in depth. So if we go for the next slide. In terms of now operating Kubernetes, there are certain things to consider. So one is obviously to implement an automatic provisioning and decommissioning based on demand. Specifically in environments where you run a Kubernetes cluster, for instance, in a dev test environment or even a production environment, it's really important on how you build your mechanisms of how to provision and how to decommission applications within it and services as well. So this is quite important because it will ease the management and maintenance load that you can have based on that. Obviously, when it comes to shorter lifecycle of containers with the advent of microservices, so this is quite important to take into account because you could have thousands and thousands of containers spinning up basically daily, if not hourly, doing certain things. Especially if you're running serverless apps, you can have hundreds of thousands of containers just spinning up and down constantly, doing whatever bit of work they need to do, and then just shut it off. So this is quite important to take into account, because what this will create is that suddenly, instead of monitoring a single application, you're actually monitoring containers which go up and down constantly, serving a function or two. Of course, you have to make it possible to easily spin up new containers. So the way you build the system and the containers and applications is that it should allow as many as containers to start without any problems, without any bottlenecks. So this goes in terms of how to lay out the deployment of a cluster to support this. Automatic placement by orchestrator. I actually talked about this sorry, earlier. So every time when something is being deployed on Kubernetes, you have to take into account, all right, so what type of service is this? Is it a backend service? Is it a database? Is it some kind of a processing thing that requires a lot of CPU? Is it a web application? What is the volume and the load I expect on it, and so forth? Because this is so important, because in your Kubernetes cluster, you can have different nodes with different capacities, and you can actually specify certain nodes with certain parameters to be there available. For instance, you can have high-power CPU processing nodes, or you can have your high-volume RAM nodes, so that you can have different source of power there for your different applications, and then you can use that to facilitate, all right, so my backend application here needs a lot of processing power, so I'm going to tell Kubernetes to always deploy it on the high-power processing units. Or you can have a case where this application is so big that it deserves to run on its own nodes within the cluster. And finally, of course, engaging broader organization is really important, because what you want to accomplish here is that you really want to have business owners to have visibility and access to the key metrics that are coming out of Kubernetes. So in our case, what we actually do, and this is also something that we're going to talk about later on, but we do use our metrics and SignalFx in this example to display dashboards and insights into the cluster and the applications to our customers directly. And having that ability to build this custom visualizations and custom dashboards that are always on, and our customers can always access and get insight into what's happening, what's going on in their cluster, what's going on in their key critical applications, is really valuable, because it saves so much effort, it saves so much time, and also empowers our customers to actually take action even before before it's too late. And of course, for us, it always validates, because we can always easily validate our discussions with the customer when we need to either increase capacity or either do something with the application. So that's it from me for now. So Patrick, over to you.
All right. Thanks so much, Marco. So now let's take a closer look at what SignalFx is offering. We've actually had the ability to monitor Kubernetes and Docker for a while, with metrics coming in, dashboards being created for you, and so on. But as the use of Kubernetes has really picked up, we've essentially rebuilt what we do for Kubernetes from the ground up, so that it does exactly what you would expect it to do, given all of the operational considerations that Marco just talked about. So there are three primary components to the new Kubernetes monitoring from SignalFx. The first is the agent, right? And this is the thing that goes and gets the metrics from the containers, the services, et cetera, that are running in the Kubernetes environment. And in a dynamic environment where Kubernetes is responsible for the placement of pods onto different nodes, you actually need to be able to auto-discover what services are running and where, and to have the associated metrics for those services being automatically collected, right? You have no time to go and say, okay, now I'm going to manually or even use some config management software to go and set up the agents. It has to sort of figure out things on its own, and that's what our new agent does. The second is that you need not just the ability to look at those metrics that are available from Kubernetes, but also to be able to show the relationships between them, right? Kubernetes introduces several new abstraction layers to make it easier for you to scale that environment, but it also then means that you need to understand how those different layers are connected to one another. And also going back to the fact that the placement of pods is up to the orchestrator, you need to be able to know where the particular pods are so that when you go and look at them, you can then start to tie any issues you might be having to the underlying infrastructure that's supporting it. And finally, we're making it easier than ever before for you to know for sure what's going on at any point in time in your environment with alerts that are capable of adapting to the dynamic or even ephemeral environment that is represented by containers. So let's go ahead and actually start demoing some of this instead of just talking about it. I'm going to switch over here now to, all right, there we go. An environment where we've got a couple of Kubernetes clusters running, one dev, one prod, not a huge environment, just large enough for us to see what kind of functionality is in here. And so at a top level, you can see that you're getting a view of the different clusters, and then we're also showing you some key metrics about them, right? You need to make sure that, especially at this level, you're understanding things in aggregate. You know, what's the membership of the nodes in the cluster, number of containers, you know, are there outliers that you need to be concerned with right away at this top level? And part of that is coming by looking at the different metrics that are coming down below, and part of that is by looking at the individual nodes and the way they've been colored. We also do have the ability to surface up alerts for an environment. In this case, I haven't set them up, so you won't see anything on that side. Now, from here, what you can do is start to drill down into the different layers of your Kubernetes environment. So if I, for example, select a particular node, what we're going to do then is refresh the screen and give you a lot more detail of what is going on with that particular node. And so we'll show you here, for example, on that node, there are 6 pods, what's the configuration of that node itself, and then again, what are the things that you need to be concerned about from an infrastructure sizing perspective, right? We'll show you what are the pods that are running on there and what is the CPU use, what's the memory use, and so on, and give that to you with a very good point-in-time capture as well as a trend so that you can see how different pods have trended over time. Now, in addition to that, there's information about the node itself, as well as metrics coming from all of the different services that are running on there, right? So if you go back to the system metrics, one of the things that we were showing you here was the different nodes that were, the different pods that are available, right? So Mongo's running there, Redis is running there, and you'll note that over here next to the services label, you'll see a bunch of other tabs that represent the things that are running on there. If I go ahead and select one of those, what it'll do is bring up dashboards that will then give me information about what is going on for that particular service. It looks like the Apache is relatively dead, so let's go ahead and take a look at Kafka, where we've got where we should have a little bit more things happening, or potentially Mongo or Redis, right? So lots of different things going on in this environment. And you can see how they're all related by virtue of this particular visualization. Now, if I then want to go and say, well, let me take a closer look at what's going on at the level of the pods, I can go ahead and do that. So I'll go here. You can see I can choose a different view of going to the Kubernetes pods. And now what it does is it will filter down the pods that are available in this cluster by the particular node that I chose, which was hosted by Kubernetes prod, right? And now you can see here's the list of the pods that are running on there. And as before, if I go ahead and select one of those, you can start to see metrics associated with that. So that pod contains a couple of containers. The network throughput is at a certain level, memory use, and so on. So all things that are useful for you when you are trying to confirm that, in fact, you've sized things properly. And we'll note here that there's Kafka running on this particular, in this particular pod, and the dashboards for that are available. Okay. So that is, at one level, what you get. You can also continue to drill down further and say, well, let me take a look at the containers that were part of this and get the metrics associated with that as well, the number of containers that are in that pod. And again, you can see from the top that it's been filtered down. And you can also note that there are 3 that are active, and it looks like there may be one that was spun down recently and no longer sending in metrics, right? So giving you a view into what's actually going on in real time with the different parts of the Kubernetes environment, okay? Now, this is very interesting views and very interesting information, irrespective of whether you are the person who is administering to Kubernetes, right? Because you want to be able to see those relationships, you want to be able to dive into successive layers and drill down and understand the relationships. And it's also useful if you are someone whose service is running on Kubernetes, right? Because having that environment makes it easy to spin things up and spin things down, but you don't necessarily know where things are running when you need to go and debug a situation. And this kind of set of views will tell you what all those connections are. Now, if you are also someone who is administering it, there's other information that you'll want to see in order to figure out what's going on, right? And so there's a variety of other metrics that are being pulled in that are easy to visualize and to be able to alert on. So, for example, we'll help you gather information like the number of deployments that are running in your cluster that may not be according to spec, right? Because when you set up the spec for the deployment, you say how many pods you want. We know how many you want. We know how many are actually available, and we will be able to tell you pretty easily if any of them are not performing as expected, right? And this is where the analytics that you have within SignalFx help you start to understand things pretty easily, because not only are you able to look at those metrics separately, but you can also just do simple math like, hey, what's the difference between those two? And then if it is above 0, then turn this red so that I will pay attention to it, right? So it's a simple example of the kind of things that you can do to better make use of the visualization so that you are actually having your attention called to what you need to pay attention to as an administrator. Another example of that might be when you need to understand whether there are a lot of container restarts happening. Looks like we've got a rather pathological case here with Kafka of having many restarts, and it's something where you might be concerned if you, say, have the dreaded container crash loops going on. And rather than necessarily having to look at this all the time, one of the things that will allow you to do is go ahead and create detectors for those kinds of situations so that you can get alerted to that particular set of problems, right? And so the capability that we provide for allowing you to look at this is to first be able to take a look at the signals, but then also be able to set different kinds of conditions that you might want to be looking for, right? So in this case, the container restarts, it might be something as simple as I want to go ahead and set a static threshold, right? If it's above some number within some period of time, that's something that I can be concerned with. SignalFx also offers a variety of additional types of conditions that you can use. So, for example, if you wanted to simply say, well, if it changes suddenly, right? Because maybe there is some level that is not abnormal in my infrastructure where I want to, where I expect things to be scaling up and scaling down. I don't need to be alerted every time that something happens, but if there's suddenly something that is highly unusual, like many restarts happening within a certain period of time relative to a lower baseline of restarts, then that might be something to look at, right? So in this case, I'll go with a simpler static one and say if it's above some number, let's say, let's see, what would be good. There's quite a lot happening in this environment here. So let's just say, whatever, if I see more than 10 happening over the course of a 5-minute period, right? Then what we'll go ahead and do is preview what kind of alerting would have happened in that environment, just to make sure that you're setting things up the right way. Okay. Now, As you continue to set this alert up, you can say, what kind of severity you want to assign to it, whether there's a run book that you want to have people go to when they get this alert, whether maybe there's a command line that you need to have them run as part of that, and then go ahead and add, I guess I'll just go ahead and add myself as a recipient for that, and go ahead and activate that as an alert rule. And now what we've got is an alert that will fire when I see some number of container restarts that are going on. And you can go back to the original view earlier, and in this case, if I were back on the architecture and on the alert side, if there's a problem, then I'll see it here in the alerts. Okay. In addition to, I guess, getting it on email and whatnot. Okay. Now, within these types of environments, you not only have to worry about Kubernetes itself, but also things that are Kubernetes itself depends on. And so just a couple more things to call your attention to as part of what we do with Kubernetes monitoring. We also monitor some of the core components within Kubernetes, one of the most important of those being etcd. Right? Etcd provides the service discovery mechanism for Kubernetes. All the information about what belongs where is stored there, and so you kind of need to make sure that it's up and running as you would expect. Right? And so we provide out-of-the-box monitoring on etcd. We'll show you how the cluster is performing. If you want to look at individual instances, what's going on, we'll show that to you as well. And again, here is where you can take advantage of the kind of alerting that SignalFx does to make sure that things are operating correctly with your environment. Right? So, for example, if I want to know when things drop below a certain level, right? So, hey, as an example here, what I'm looking at is, I guess, just the number of instances that are leaders and the number of instances that are followers. And if I want to go ahead and say, well, what I really care about is the total number of instances that I have in the environment, and that's what I want to alert on instead. And what I want to do is say, if it drops below a certain level, right? In the case of etcd, there are different kinds of failure conditions. It might be the case that you want to be alerted if a minority of the instances go down. We can do that by looking for, let's say, a sudden change in that kind of situation, where you say, hey, alert me if it's too low, and let me go ahead and define what too low means. Maybe it's a percentage change from the norm, and if I drop below, let's say 30% below where I was, that's sort of a good example of a minority number of instances dropping out, right? And I can go ahead and tune those numbers to be, if a majority goes down, and say whatever. If more than half of them go down, then that's when I want to be alerted. Okay. I'm not going to go ahead and run the rest of this because I think you've already seen the rest of this flow. But point being that the kinds of conditions that are built into SignalFx are really good for monitoring not just these dynamic environments, but also the clustered ones where you need to understand how the aggregate is behaving and when there are larger patterns at work. Okay. All right. The last thing I'll show you really quickly is what we do down at the container level, because it's important also to understand when you are debugging things exactly what's going on, right? And in the case of any sort of abstraction layer where resources are being shared, you typically need to make sure that the resources that you expect are actually being apportioned out correctly to the containers in question, right? This is any platform that virtualizes the underlying physical resource and where you have the ability to overcommit those resources shares this kind of problem. Containers are not immune to that, and so Docker does provide a number of stats that help you understand what the shares of the CPU are being used, what the quota is, and whether there are points in time where a container, despite what it's asking for, may not be getting that, right? And we'll show you if there are periods where it's being throttled and the amount of time where that's happening, and also show you the memory that's being used by those particular containers. Okay. All right. So let's go back here and review quickly what you've seen. First thing that we didn't show you the actual act of installing the agent, but we did show you the fact that when you are running this agent, what you're able to do is see the different things that are running on top of particular nodes and pods within Kubernetes, and we'll show you where they're running so that when you are trying to figure things out, you don't have to go anywhere other than SignalFx to understand those relationships. We also showed you the visualizations that help you navigate from top to bottom, from the cluster level view down through the pods and nodes, and also looking at what's in the containers. And then also monitoring for etcd, as well as, by the way, all of the different services that are actually running in those pods. And the last thing we showed was the ability to do alerting optimized for these high churn environments, and the good number of built-in conditions that really help you find patterns and trends across your dynamic environments, right? Looking for things that matter in the aggregate rather than trying to pin down any particular single container, because that is not going to be the thing that matters when you have an orchestrated environment, making sure that it's running the right way for you. Okay, with that, let me turn it back over to Marco.
All right. So our key benefits to date with SignalFx, I would have to stress, first of all, that one of the really, really cool things with the Kubernetes integration is exactly what Patrick highlighted in terms of what pod is running where, and most importantly, the amount of hardware resources it uses, because this is so much important when you're managing Kubernetes that you actually can get a really quick glimpse into, okay, these pods are running on that node, this is the amount of CPU RAM usage they have, so this gives you a very quick insight into the current state of the cluster. On top of that, obviously, we have a lot of benefits with the highly configurable views and alerting we just saw across basically everything, so nodes, containers, services, and applications. This provides a very nice, easy way to get all of this set up and to have quick insights, but also to have very, very good alerting. There's a lot of integration out of the box, especially the Kubernetes integration we've seen, but there's 100+ integrations out there that obviously are a huge benefit, such as database integrations and middleware integrations, Kafka, and everything else. We, as you know, we run quite an operations team, so PagerDuty and Slack are obviously quite important for us, and those integrations work flawlessly out of the box, simple to set up, and off and you go. Real-time metrics collection is one other thing that SignalFx allows us to really get that real-time metrics collection on the very much highly critical services that we run, and this provides us a quick and easy way to get everything at the current state, what's going on, especially in those situations when things are burning and things need to be sorted out real quick. And of course, the dashboards are very easy to use. As I mentioned earlier, we do have dashboards set up for customers, and these are really important because you can abstract key metrics and aggregate them up to a dashboard and have it really simple for operations teams or developers or customers or business users to have an insight into what's going on. If we go to the next slide, what's next for us in terms of where do we want to take the SignalFx work that we've done further is that we really are eager to explore integrating SignalFx into customer applications. SignalFx offers quite a good API that allows you to actually hook in that metric collection inside applications, and this is something that we're really excited about and we really want to try out. We want to basically integrate SignalFx API within applications and collect metrics from an application use cases point of view, so business processes and stuff like that. Then we really want to have an implementation, and that's something that we're going to focus on next, to have Kubernetes scaling triggers based on data from SignalFx. So basically use the data that we have in SignalFx and then trigger different scaling and different distribution as well of services and applications throughout Kubernetes. We want to set up more data views for customers so that they can get more insight, and this goes hand in hand with the previous bullets, where if we have the ability to have our customer take a look into their infrastructure, but most importantly, how that correlates to the data and the metrics coming in from their applications, and really easily correlate. All right, so my application is running on this cluster here, and this happens basically when this certain business processor being used in the application. This is how it relates to my infrastructure. And finally, fine-tune alerting and detection, especially for high availability services. Obviously, the alerting capabilities and detection capabilities of the SignalFx platform are quite powerful, and this is something that we really want to invest more time into, really fine-tuning it down to very specific events, and hopefully get to the point where we can have as much as automated procedures kicking off based on those detection and alerting policies that we're going to set up in SignalFx. That's it for me. Thank you.
All right. Thank you so much, Marco. I guess, Charlene, I'll turn it back over to you.
Okay, great. We are looking at the question and answer period of today's webinar. So if you have a question for either Patrick or Marco, please feel free to use that control panel, submit your questions, and hopefully we'll have time to get to them. We've already gotten quite a few questions in so far, so let's go ahead and dig right into it. We have a question from Vigramjit, who asks, how easy is it to implement, how easy is it to implement Kubernetes with big data projects? So Patrick, I think this one is for you.
I think implementing Kubernetes is actually Marco's specialty.
Ah, okay.
Yes. All right. So yeah, I can take that one. So when it comes to implementing Kubernetes for big data, obviously there is quite a setup that you need to take into account. Basically, the tools, the big data tools that you're going to deploy. I can tell you from our experience, running Hadoop with Spark inside Kubernetes has been really great experience. So there is still a lot of work for Hadoop, Spark, and all the other tools within that domain to build more distribution and integrations with Kubernetes to make it even better. But overall, I would say that where we are today, it's definitely worthwhile to deploy on Kubernetes a big data platform. And there's a lot of benefits, obviously, versus a traditional cluster deployment, because Kubernetes gives you all this modern container-based approach. So, the gist of it is that I would just say good planning, especially on the processing part, and then obviously on the data part. So a combination of a really good, high-powered, high-volume NAS or SUN solution is always great, or some kind of a scaling software-based volume manager. And then when it comes to running the services, then Kubernetes really, takes out everything basically, and it really runs all the big data stuff really great.
Okay, great. Next question is from Kevin, who asks, what about Windows workloads? Kubu supports this, and there is a lot of lift and shift of these initially into containers. Do your solutions support this?
Yeah, I'll go ahead and take that one. So the answer is yes, we do monitor Windows environments as well. I apologize for the somewhat Linux skewed view of our demo environment, but yes, it's definitely on the list. If you go ahead and look at signalfx.com/integrations, you'll find the list of things that we support from a visibility perspective, and Windows is certainly on that list.
Yeah, and just to tie it into that question, so yes, Kubernetes does support Windows containers, and the SignalFx solution will just work fine with the Windows-based containers on Kubernetes as well.
All right, great. Next question is from Parth, who asks, can this be integrated with Rancher, and does it provide, I'm not quite sure exactly what this means, and does it provide how based on custom metrics?
So with respect to Rancher, the answer is yes. It does take a slightly different configuration from the standard. It is something that's documented. If you go ahead and look at docs.signalfx.com and look for the Kubernetes deployment, Kubernetes monitoring deployment guides, will tell you what specifically needs to be done for Rancher. I think the second question is about the ability to take in custom metrics, and I think that you know, that's actually something that has been a core part of SignalFx from the very beginning. You know, many of our customers send in custom metrics using a variety of mechanisms, whether that is instrumenting the code directly, using client libraries, or sending in through statsd and whatnot. And all the mechanisms that I showed around being able to go ahead and create your own charts or create your own alerts take advantage of the fact that we don't have a particular bias towards custom metrics one way or the other. You know, those are things that are very easily accommodated. There are also things that can be added to the list of what is discovered in the environment. So again, I'll point you to the documentation, but what we're doing with the agent out of the box is looking for things that we have built-in integrations for, right? But I think it's pretty common to say, hey, I've got this custom service running over here, and I want to have that be discovered by the Kubernetes solution, and you can go ahead and configure it to go and look for that based on things like the names of the containers or the network ports that are being used. There's a variety of different kinds of things that you can look for to be able to map that correctly.
Excellent. Okay, great. Next question is from Anita, who asks, who can configure the alerts? Does it need to be the admin of the monitoring system, or can the container owner do that?
So I didn't go through this in gory detail in the beginning, but one of the other principles, I think, in the environments where you have many development teams involved in operations is that monitoring effectively needs to become a self-service activity, right? Because you don't expect at that point a centralized operations team to have full knowledge of or full control over the environment, right? And so what I showed you there was just as a regular user. I can go in and set up alerts that I want based on the information that I'm more likely to have as someone potentially who built the software. So fully available to folks that are not admins.
Awesome. All right, great. Doing a quick time check here. We're about 8 minutes to the top of the hour. We have time for a few more questions. If you do have one for Patrick or for Marco, please feel free to use that control panel and get your question in. We've got a couple left here. Venkataswaran is asking, does it display the application or container logs?
So SignalFx itself is primarily centered on metrics, and so we do take in logs as a metric source, but we convert them to metrics for viewing, right? And so there are also the ability to look at events if they are important things that you want to go ahead and correlate with the metrics themselves. And so oftentimes what we'll see people do is send in as events, probably scraped out of the logs, things like you know, deployments of things or code pushes and that sort of stuff. But we're not a log tool as such, not for log aggregation or analytics. I think you can think of us more as a metrics aggregation and analytics platform.
All right. Great. Next question is from Vardhan, who asks, what would be the role of monitoring tools like App Dynamics vis-a-vis analytics provided by Kubernetes?
So App Dynamics, as far as I recall, is an APM tool, right? So I mean, App Dynamics is mostly going inside the tool and providing you with metrics that are relevant to the application itself and tie into the application code. Metrics on the other hand, are more for the operational part. So how everything is operating across all the infrastructure, nodes, containers, and so on. So where APM would give you more business insight and hooks into the actual runtime code, metrics are more for giving you the overall end-to-end view of things and are more for scaling architectures. Mm-hmm. Maybe Patrick can tie into that more if you want to.
Yeah, and I think that's really kind of the high point around that question, right? APM, like AppD, New Relic, and so on, has a great role in helping to do performance troubleshooting when you are looking at the code itself. It's a little bit less useful, I think, in environments where you've broken things down into microservices, because then it's going to be the boundaries you know, across the different services that matter at least as much as what's going on inside. And so I think, you know, kind of looking forward to what will end up on Kubernetes type environments, if you think about service meshes and the fact that projects like Istio will be able to show you dependencies across different microservices and help surface the important metrics there. I think you'll see the role of traditional APM becoming a little bit less relevant in these environments.
All right, great. Next question is from Alexander, who asks, is there Node.js integration?
Yes, there is. So there is a client library for that. Again, I'll point you to the integrations page, and you can go ahead and see how to grab the metrics out of your Node apps.
All right, great. I think we have time for one more question here. Veridan has another question. How does Mesos Marathon compare with Kubernetes? Is Kubernetes becoming the de facto standard?
Yes, so I think definitely where we are right now and looking at not just what we are doing with our customers, but also looking into the community and essentially companies out there, Kubernetes is really swiping the floor with Mesos. It is now being deployed much more than Mesos for sure. It is the most contributed project on GitHub. So if I have, you know, if I take those two right now, I would say Kubernetes is definitely the winner. And I don't see that changing just because of the amount of time and effort and just usage out there of Kubernetes is just fast compared to what Mesos Marathon is and how much it's used today.
Okay, great. Well, that is all the time that we have for the questions today. I would like to thank everybody who did submit a question, and I'd also like to thank Patrick and Nikos for taking care of answering those questions. And I'm just taking a look. Do we have one more slide here, Patrick? I think I thought I
no,
saw
I don't believe so.
I
think just a little bit of a pitch for finding out more. Obviously, I've talked about it in answering the questions, but you can read up about what we do around Kubernetes and, of course, try out SignalFx as well.
Okay,
right.
Great.
Thank you so much.
Great. I would like to thank Patrick Lynn, and I would like to thank Marco for being our great presenters today. You guys did a great job, and I would like to remind the audience also to check back on devops.com for future webcasts. We've got a ton of them listed there. And then also check your email for a link to today's webinar, which will be available on demand probably in a couple hours or so, along with the slide deck. But for now, my name is Charlene O'Hanlon. I'm the moderator for today's event, and I wish you all a good day. Thank you.
Thank you.